Hi everyone, and welcome to my talk about being dev ready in minutes, not days, and how we achieve this using Terraform Cloud and open source modules. So my name is Stephen. I am a mission critical engineer at Schuberg Philis, and people often ask, what does a mission critical engineer do? Well, Schuberg Philis is a bit of a niche company where we manage the critical IT in some of the key industries in the Netherlands. So we focus a lot on finance, payments, logistics, banking, that sort of thing. But what I want to talk more about is how we engage with these customers and how we have a single KPI. And this KPI is the 100% functional uptime. And what it takes for us to be able to provide this KPI and this way of working. So typically we're engaged with the customer. We run the whole infrastructure stack so we can provide this KPI. But more recently, customers are coming to us and asking us to help them either by being in their teams or running platforms for their teams rather than running the actual applications. So this is how we basically engage with a customer or a prospect. We build a team, and it's one team that is through the whole life cycle journey of this customer. So you see the same people who are there for the initial process and the proposals, through to the initial plans, the build phase, and the run phase. And these teams are self-steering, they're autonomous, and they have all the power to do what they need to deliver this 100% KPI and deliver on this promise. So yeah, all choices are theirs. So you can imagine this model is really fantastic for innovation. You have all these teams who are solving customer problems, and I think we build pretty cool stuff. But we have a problem with standardizing, and there can be lots of like reinvention and unnecessary work, basically. And today I'm going to talk a bit more about how we use Terraform and Terraform Cloud to bring some consistency and to reduce the time it gets to be dev ready. So I lifted this from one of our sales decks, actually, but I think this probably resonates with anyone who's on a cloud journey. You have your how you want to use the cloud to get value back quickly. You want to be safe and compliant, and you want to be able to enable your teams. And so when we chat with customers, they say it shouldn't take months to stand up an environment. They want to have a safety net around their workloads. We often hear things from developers who are new to cloud that I'm scared to create an incident. I'm not too sure what I'm doing. How can you help protect me? And then finally, to really get the most value out of the cloud, they want teams to have autonomy. And if they have the ownership, then, well, there's more success. There's no throwing over the fence. Yeah. So we have embrace the concept of the enablement engineering and came up with the enablement platform. And it's basically two parts. There is the foundation and the services that we use, but at the end of the day, it's all about the workloads. And so from a platform point of view, we don't really mind what is in the workload. We're more about giving the teams the freedom and the flexibility to do what they need to do, having the ownership and autonomy, and that safety net that we'll get to in a bit. And then we really encourage teams, for how we start out in this journey, was we encourage teams to do everything themselves. So really, own the end-to-end. But then, as we saw more common patterns across different teams, we started to pull those out into a service layer. So we talked about things like vulnerability management. We talked about out-the-box monitoring. Backups should just be, setting a tag, maybe even provision your own workloads, all that sort of thing. And finally, we get to the foundation. And the foundation is made up of two parts. It's the organization management, so that your whole environment. And then we talked about the account vending machine. And that's what I want to focus about today, how we do the repeatable deployments of our accounts and pipelines and associated services. So what is dev ready? So for us, this is really the moment a team can start being productive. The environment is ready, they can log into it, any services that they need are then available, and they can basically get to work and start delivering value and building some stuff. So I work more with AWS teams, so I'd like to share an AWS example. If you look at the most basic version of what DevRate would be for someone, we're talking about the account being ready, a Terraform Cloud workspace is created, we have a code repository, and any necessary services are configured to actually use that account and services. So let's take you through what it looks like. We have a Terraform plan. It's going to run in Terraform Cloud. It's going to reach out to AWS and talk to Control Tower via the service catalog, and it's going to provision an account. And once the account is created and it's been enrolled and all the policies are done, then the resource in Terraform says that it's complete, and then we actually assume a role in that account, and we create an ORDC provider, and we create a few IAM roles to actually use. The next step is to then talk to Terraform Cloud. So we actually have a Terraform Cloud run, talking back to the Terraform Cloud API, and that's going to create a workspace that's going to consume that role with the ORDC provider. So no static credentials, it's all dynamic. And we have a baseline workspace that we also hook up, which I'll get to in a bit. Next, we create a repository inside GitHub, and this repository is going to have all the files needed to use the workspace. So, for example, any backend config, any variables you need, that sort of thing, as well as hook up our baseline repo to our workspace, which I'll get back to in a sec. And finally, we are using Okta in this example for our IDP. So we create a group in Okta. We're going to create some permission sets for different roles inside AWS, a GitHub team, and a Terraform Cloud team. And then we manage all the RBAC and do push rules in Okta, so basically all the logic is there. And if a user is dropped into that group, if all goes well, they log into the Okta dashboard and they're greeted with these 3 buttons. So how do we do this? When I do this sort of thing, I have to show you something more concrete. And this is like the modules that we're using. So on your right-hand side, we have the left-hand side, you have the actual module like configuration via your locals. And we set some variables there that are going to be reused across different deployments. And on the right-hand side, we call our module our AVM module, so our account vending machine. And then we specify things like the name, some tags, and then we take some default values, and we're going to merge in stuff specific for that workload. I want to draw your attention to the workspaces variable, because pretty much once we've deployed this once, we don't touch anything on the right-hand side. It's all happening on the left with the workspace configuration. And for a more logical overview, then we start like this, where we have GitHub on the left-hand side. The users can push their code into GitHub. This is going to trigger a plan inside Terraform Cloud, and then push those changes through to AWS. The baseline now comes into play. So with the baseline, it's a single repository that we use across every environment. And this is so we can do things that are not able to be done from like a cloud environment control level. So maybe every account should have a VPC. Maybe every account should have a KMS key. Maybe we have policies like you can't create volumes without KMS. These are things or resources we can set in the baseline and roll them out everywhere. And just to show you how this looks, the developer teams get to work on the top, and they have no idea what we do at the bottom. It's fully under our control. So when we talk about this way of working, it's probably quite a familiar image. We get the app teams or dev teams to push their code into the GitHub repository, and that's going to create when they create a pull request, we'll create a job inside Terraform Cloud, and that's going to run any checks, any plans, and they can keep pushing to that branch until they're ready to merge it. Once that's been merged into master, they are then able to either have it auto-applied or manually applied, depending on their risk appetite, and from there just deploy it out into whatever resources they want to manage. So the different view on this is how this is actually managed. So from a platform engineering team, we sit on top, and we are managing all the modules inside the private registry. And from a security perspective, it's either a security team or actually us working on behalf of a security team where we're creating Sentinel policies. And these Sentinel policies contain anything from business requirements like certain required tags or allowed regions or that sort of thing to naming conventions and that sort of thing. What we try to do with the Sentinel policies, which is quite a bit of work, is to replicate everything that we have as a constraint in the cloud. So there's nothing worse than having your plan be all green, you merge the code, and then when you deploy it, you find, well, actually, you're not allowed to deploy to that region, or you're missing a tag on a resource. And then you have the situation where you basically have bad code merged into your main branch, and then, well, you have to go back and fix it. So when the developers are pushing code to their repository and starting a workspace, we know that, or they know rather, that if they can keep pushing that branch until it goes green and have a high rate of success if they have a green light from Terraform Cloud. So again, I want to come back to this workspaces module. So I can imagine that when you look at this, you think, well, it's great to have one workspace, but in reality, this is not how it goes. So as developer teams get more mature, we encourage them to split up their state and split up their workspaces so that so they have, like, smaller blast radius, and they can have different resources for different risks. So if I think about creating an RDS instance or an S3 bucket, put deletion protection on there, then that's a great candidate, I think, to put to its own workspace and have it on auto-apply. Because if you do something wrong, then the actual resource and the provider is going to stop you from having an error. But maybe some other resources don't have this protection, and then you want to have the manual check. That's really up to you. And so when this module runs, the same thing happens. It's going to generate the directory, generate all the configuration. It's going to add another workspace, and then you're able to move your code around and start, still having the same account, still have the same baseline, but you're able to cut up your resources as you desire. So why Terraform? So to start, Schuberg Philis has a long history with Terraform. We started using it in 2014. When I joined the company in 2015, we were already using Terraform to provision internal cloud resources. And I think the concept of a state machine really appeals to us. The fact that if it has an API, we can manage it, we can store the state, we can inspect it, we can update it. And I think the sheer number of providers that we have, it makes it, I think, like a no-brainer. If I come back to those teams who want the autonomy, then they're able to use Terraform and choose different services as they want. So when we start on our journey, this is what it typically looked like. We had Terraform with AWS and using GitHub as our code repository, and Okta as our RDP. And then quite often we had Datadog as our monitoring platform. And then we can do things like team access and automatically scraping resources as they're deployed and that sort of thing. But to give a more concrete example, you can just as easily swap out Datadog for something like Sumo Logic. We most recently, maybe a year ago, added support for GitLab, so that will swap out GitHub. We often get asked about why Okta. We already have Azure AD or Azure Microsoft Entra ID. We don't want to have two IDPs, so we're going to swap that out also. And now at the moment, we're working more to get Amazon as also a replaceable unit, so we can even put Azure there. And if we wanted to go further, we could even change GitLab to use Azure DevOps. And if you really want to go fully into it, you could change out Sumo Logic to use the Azure metrics. And I think when we have this pattern of having a code repository that's backing a Terraform Cloud workspace, whether it be the VCS mode, where it's all like user-friendly and easy for you, or to use the API mode, where You have a bit more control and actually make pipelines, you roll things forward and roll things back. It's really powerful. So why Terraform Cloud? A question I often get asked is, why do you need this? We've done this for years without it. We don't need it. We can build this stuff ourselves. And to a degree, I think we could. There are some smart people out there, but I think the mind shift is that we are not here to build services, to deploy services. We want to be more integrators. So there's a few key points I want to talk about, and that is the access management. So another problem that is really difficult is people talk about the state. How can we have this the state thing has all the credentials? And with Terraform Cloud, it's really easy. You push a button, and then you can't read the state. You can read the outputs, but nothing else. We're able to have teams limited to different workspaces, so I can have users just moved around in Okta that are propagated to different teams in Terraform Cloud. And we like to drive a least privilege model, so no one actually has an overarching permission set. Everyone's really stroked down to what they need to do. The job queuing is something that maybe sounds easy, but to actually implement this yourself is extremely difficult. You can imagine if you have, say, a more risky environment or maybe risk-averse environment, and you merge something, and then you wait to do the manual apply, and then someone else has a quick fix, and they merge that, and they push it through, and hey, presto, you have a free update from your change. And what Terraform Cloud allows you to do is to run these jobs sequentially. So if you want to actually do a manual inspection, you have the choice to opt out and to do a conscious discard of the run. And additionally, the data deployments, having this manual date to say yes or no is really, really powerful. So I spoke a bit about the sort of customers we engage with and how important it is to codify policies. Using Sentinel took a lot of work, but we were able to translate everything as a policy, basically, and guide people to the best way to do something. And they get feedback from the machine, which I think is the best way. If you have someone do a code review and do a manual comment, it's not, I think, as good as the machine telling you, actually, this is the wrong setting, please do a fix. And finally, the private registry. Some customers speak to us and they say, we want to have an approved list of modules. How would we tackle this? And so what we do is then publish modules into the registry, and then again have a policy to say you can only pull modules from this registry. And this has not been without challenges. So this journey started about 4 or 5 years ago, maybe a bit longer. And at that point in time, there was no way to create AWS accounts programmatically with Terraform using Control Tower and such. So you had the option to create the account using the AWS organizations, but then there was a manual enrollment step. There was always a manual tweak. So we actually created our own provider, and the provider reaches out to the service catalog API, and from there we can actually poll the API until the account is created. And when we get a response back, the resource is marked as completed, and we move on. And I think we really like getting the feedback in Terraform, and at that point in time, I think the suggested way was to trigger a Lambda, but the Lambda we felt was fire and forget. You have to then wire up additional ways to get notifications, and keep it native is best. So another pain point we had was the backend.tf, so your cloud configuration. There was a real pain point where you create the workspace, you create the code repository, the workspace by default. Now you can actually turn it off to have a default run, but when you create the workspace, initially you always try to do a run. The configuration was never there, and so the workspace always failed. So every workspace had, a failed job to start with, which doesn't look good if you are rolling this out to developers and teams. And so we actually created the GitHub repository file resource, and we used this to template the file using all the data that we have in the workspace and from our AVM module I mentioned earlier to create this resource so that out the box they have any variables, have any backend config, maybe even some data resources, anything to get them not fast-tracked, right? the whole goal was to how we get these people productive sooner. And then finally, or most recently, I think what we've just overcome is the repetition, I guess, we have of the AVM module. So for those who are more familiar with Terraform and using nested providers, you'll know that you can't use a for each on a module if the module has the provider. And what we do is we have one provider that is creating the accounts via the service catalog, and then we instantiate another provider that's using the accounts of the account that was just created. So we can't loop over it. And for this, we actually introduced CDK-ATF. I think to illustrate this point, this is what it looks like when we were, like how, until the last few weeks, how we were deploying these different workloads. So on the one side, you see dev, on the other side, you see prod. But if we look at it, this is the only difference. So we have the names, and maybe some email and environments, and some OUs. And it was really frustrating that every time we had to provision a new account, to of course you have the account, and the workspaces are just going to that same account, we had to copy and paste this block, and then change a few fields. Yeah, really it just didn't feel good to do this sort of manual labor to provision a new environment. And so we introduced CDK-ATF, and for those that don't know about CDK-ATF, it is a way to give you a, a more programmatic way to create Terraform resources. So there's a few supported languages like TypeScript, Python, Java, and that will create some Terraform code for you, and then we can follow the usual API or method of pushing to Terraform to deploy out our resources. And again, it's nice to share how we tackled this. So the locals you saw before is, well, how we do with HCL. And then we ported that to YAML. It could be JSON, because it could be anything you want really, because now you can import stuff as you like. But I think what's nice is that you see the account defaults, the baseline workspace, and the workloads are now distinct different keys. And so if I show how we actually use this, having a programming language and now generating the code, we can actually source this configuration from different files. So from a platform team, we can read a YAML file and say, this is our baseline defaults, and from an application team, give them their own configuration file and let them configure their workspaces and environments as they see fit. And at the end of the day, it's just going to, well, with that said, that we can basically enforce our own defaults and standards. So when we give them this very thin API of a workloads key, and for this example, we're talking about that YAML file that sits in their environment, they have no access to set any of these other fields. So we can have our account defaults that they can't touch. We can make sure that we always have, for example, a boundary policy. They have no way to alter the possibility for our baseline workspace. And so this really gives them what they need to do for their job, and lets us keep control to do our job. And when we actually run this code, we get, well, the CDK-ATF inits would happen beforehand. We run a synth, and the synth is creating a bunch of JSON files. And if you want to debug something, you can actually cd into the directory and run the Terraform Consul. And it's just normal Terraform, just in JSON format. Once you run CDK-ATF, we basically package up this code, and it maps out dependencies between different stacks or different workspaces. So for example, provisioning the teams before the RBAC, but after the accounts, something like that. And then we follow our usual development workflow. So we have the same Sentinel policies, we have the same checks, the same manual dates if you want, or auto apply, but it fits into the same ecosystem. And something that's nice to mention is that now we have this model, or this the structure in place. The example I gave was just with using a YAML file. We could just as easily have something like a DynamoDB table. You could front that with an API, and then have a way to post data to the API, lands up in a DynamoDB table, and then that triggers the Terraform Cloud run. So you basically have now got a way to even programmatically have an API to manage your environments. Or do custom integrations like some of our customers have done with Jira and ServiceNow, because their customer, that's their approval flow. So we try to fit into that ecosystem. So when it comes to takeaways, map out your journey of what dev really means. I mean, for this presentation, I'd have a very basic version just to illustrate the points and how we map things out. But it could be as big or as small as what you need for your environment. Don't be shy to include manual steps, because remember that this is going to be an iterative process. Like I say, this was like a 4-year journey of like nothing, and writing our own resources and providers. So now we have a module that we just push a button. And when it comes to deploying this sort of stuff, I really think it's worthwhile to look out and see what is out there rather than building yourself. I think we have a strong culture of reuse before build, or at least that's what we are moving more and more towards with these sorts of patterns. And finally, please check out our module, the AVM module. It is one of a few, but I think this one illustrates the pattern of having a workspace backed by a VCS. Yeah. And finally, the question, so how long does this take? I think I went a little bit too quick, but we're talking at about 14 minutes. And so for the time we actually merge a pull request, this is the time it takes for the Terraform Cloud agents to be aware of the job, to run the plan, pass all the Sentinel checks, do the auto-apply, and in 14 minutes we can stand up this environment with RBAC and everything for someone to go into the application with Hoekstra. So which means that if I was a little bit slower, we could have actually had 2 different deployments done in the time that this torch has taken. Yeah. Thank you so much. It's been great to talk to you and to share what we are doing. If you want to get in touch or learn more about Schuberg Philis, please check out the link tree or the QR code. We also have links to our modules and to our providers. Thank you.